In this lecture, we want to begin our study of exponents. Specifically, what we're going to do is we're going to look at exponential expressions, and we're going to talk about how you simplify them. And to learn how to simplify exponential expressions, what we need to do is we need to talk about the rules of exponents. And there's a lot of rules we're going to go through. So I'm going to go through in this order. I'm going to talk about the product rule, the quotient rule, the zero exponent rule, the negative exponent rule, talking about using the power rule, find how you find the power of a product, how you find the power of a quotient. And then the last thing we're going to do is we're going to talk about how you simplify some much harder exponential expressions. And throughout this lecture, what you'll see is I'm going to introduce a rule, and then I'm just going to work a ton of examples just so you can get an idea of how to use these rules. Okay, so let's start with the product rule. So in multiplying exponential expressions with the same base, they need to have the same base. What you're going to do is you're going to add the exponents. So you use this sum as the exponent of the common base. So what you look here, if you have b raised to the n power times b to the n. So the b's here are the bases, okay? And you have the exponent m and the exponent n. All you're going to do is you're just going to take the two exponents and add them. All right, so for example, what we're going to do here is what we want to simplify the following. So let's take this first one here. Let's look at x squared times x cubed. So if you notice, the base here is the same. The base of each of these exponential expressions is x, so this would just be x to the 2 plus 3, because you're just going to add the exponents, which would be x to the 5th power. Or if you want to actually put some numbers to it, if you were to take 2 to the 4th power times 2 to the 6th power, well, notice here the bases are 2 is the same. So this would be 2 raised to the 4 plus 6, or 2 to the 10th power. So we'll just leave it like that. We won't actually figure out what 2 to the 10th power is right now. All right, so let's check this one here. So let's multiply this expression next and use the product rule. So see here, in both of these cases, whenever we have a common base, we just add the exponents. So here, I want to take this crazy expression here, all right, this 4x cubed y to the 4th, and multiply it by 10x squared y to the 6th. All right, well, all you're going to do, you're going to first take the coefficients. You're going to take 4 times 10, and then you're going to take x cubed times x squared, and then you're going to take y to the 4th times y to the 6th. All right, well, look here. What's 4 times 10? Well, that's just 40, obviously. All right, x cubed times x squared. Well, look, common base, so you add the exponents. So whenever you multiply common bases here, you add the exponents. So 3 plus 2 gives me x to the 5th. And here, same deal. You have y, so y to the 4th times y to the 6th would be y to the 4 plus 6, or y to the 10th. All right, let's try this one. All right, let's do a second example here just so you can see. Let's take 2x cubed times y to the 5th, and let's multiply that by 12x to the 7th, y to the 6th. All right, so again, let's just set it up. Let's take the coefficients. So it's going to be 2 times 12 times x cubed times x to the 7th times y to the 5th, y to the 6th. All right, well, very simply, what's 2 times 12? That just gets you 24. And then again, when you're multiplying, you add the exponents. So 3 plus 7 gets me x to the 10th, and 5 plus 6 gets me y to the 11th power. All right, so let's move on. So that's just using the product rule, okay? Now let's move into the quotient rule. So when dividing exponential expressions, right, again with the same non-zero base, right, what you're going to do instead of what we saw here when you multiplied, you added the exponents here. So when you're multiplying, you add the exponents. Here, what you're going to do is you're going to subtract the exponent in the denominator from the exponent in the numerator. Okay, you're just going to use this difference, so you're going to subtract. Okay, when you have a quotient of two common bases. Okay, so you're going to use this difference as the exponent of the common base. All right, so let me do some examples here so you can see this. So let's take the first one here. Let's take x to the 7th and divide it by x to the 4th. Well, look, you have common base, okay? So you're going to have b to the m divided by b to the n. All right, so all this is going to be equal to is you're going to take b to the whatever the exponent is in the numerator, or excuse me, yes, in the numerator, and subtract away the exponent in the denominator. So this is going to be x to the 7 minus 4, or this simplifies just to x cubed. Let's try this one. Let's take 5 to the 10th power and divide it by 5 to the 8th power. Well, look, they have common base. All right, so you're just going to take the exponent in the numerator and subtract away the exponent in the denominator. So this would be 5 to the 10 minus 8. Well, 10 minus 8 gets me 2, and 5 squared is just 25. Let's try this one. Let's look at 12 x to the 10th divided by 6 x to the 7th. All right, well, take this coefficient here and just simplify this. Like what you're first going to ask yourself, what is 12 divided by 6? Well, that's just 2. And then it's going to be x to the 10 minus 7th power. So this ends up just being 10x cubed, because 10 minus 7 gets you 3. All right, so just to recap here. So in the product rule, when you multiply, you're adding the exponents. With the quotient rule, when you're dividing, you subtract the exponents. All right, let's try this one here. This one's a little bit crazier, okay? So taking this here, if you want to help see here how you're gonna break this up. So I have 27x to the 14th, y to the 8th, divided by 3x cubed, y to the 5th. You can break it up a little bit easier and write it as 27, take the coefficients, and then I have x to the 14 over x cubed, and then I have y to the 8th over y to the 5. If it helps, you can do that. So now just tackle it piecemeal, right? So like what is 27 divided by 3? Well, that's just 9. All right, x to the 14 divided by x cubed. Well, you're going to subtract the exponents, right? So this is 14 minus 3. And then you're going to do the same thing with the y's. This is y to the 8 minus 5. So this just simplifies to 9. X 14 minus 3 gets me 11. 8 minus 5 gets me 3. So again, it's just following the rules. Just direct application of the rules here. All right, so the zero exponent rule. If b is any real number other than 0, if you take any number and raise it to the 0 power, it is always equal to 1. Always, always, always. All right, so for example, if you take the number 1,000 and raise it to the 0 power, doesn't matter what it is, 1,000 raised to the 0 power, that's just 1. All right, now let me write the next two so you can see a subtle difference. So this one here is I have 3x to the 0 power. I want to simplify that. And then I have 3x in parentheses raised to the 0 power. You're going to get two different answers here, actually. So look, the only thing that has the exponent of 0 is x. So x to the 0 power, well, anything raised to the 0 power is 1. So this is 3 times 1, which just gets me 3. And then notice, everything in the parentheses has the exponent of 0. So it doesn't matter what it is. All of this raised to the 0 power is just 1. So the subtle difference here with the parentheses, without a parentheses, will change the answer. So pay close attention to that as you work these problems. All right, now let's talk about a negative exponent, okay? So if b is any real number other than 0 and n is a natural number, okay, then you have the following. If you have b raised to the negative n, you can get rid of the negative exponent by turning it into a fraction, basically. So this is equal to 1 over b to the n. All right, so for example, if you have (5 to the negative 2), oh, negative exponent. So I can make it positive by bringing it down and just rewriting it as 1 over 5 squared, okay, which is equal to 1 over 25. How about this one? Let's try this one. So if I have 3x to the negative 6th, y to the 5. All right, notice here how I have the negative exponent with just the x. So the way I can make this a positive exponent is I can just bring it down as a fraction. So that means the 3 and the y to the 5th stay in the numerator, and the denominator just becomes x to the 6th. There's also an extension to this rule, okay? And it's if you have a negative exponent in the denominator, okay? So here we just had b to the negative n. Well, what if you have 1 over b to the negative n? Well, you can make this positive, this exponent positive, by bringing it up. So this is an equivalent statement here to this one here. So for example, if you had this, 1 over x to the negative 5, you can make this exponent positive by bringing it up from the fraction, from the denominator. Also, for example, if you have something like this, 17 over x to the negative 12, okay? This could come up and become positive as 17 times x to the negative 12. And I just want to do one last one. You have to be careful. If you have 1 over 3x to the minus 4, well, only the x has the negative exponent. So that would come up and be x to the 4th, and the 3 still stays down in the denominator. Okay, so just be mindful of that. Like, you know, only the x there has the exponent. All right, let's now talk about a power rule. Here it's powers to powers. So when an exponential expression is raised to a power, what you're going to do is you're going to multiply the exponents, okay? So this is what we're seeing here, all right? The big one here is when you multiply exponential expressions, you add the exponents. When you divide, okay, you're going to subtract the exponents. Now here, when you have a power to a power, you're going to multiply. So you're going to place the product of the exponents on the base and remove the parentheses here. So if you have b to the m power, that raised to the n power, this just becomes b to the m times n. So you're just going to multiply the exponents. So for example, let me show you some problems. Suppose I have this. 3 cubed squared. All right, so no, it's a power to a power. So this just becomes 3, and you're going to take the exponents 3 times 2. Well, 3 times 2 gets me 6. And 3 to the 6th power is 729. Or how about this one? If I have b to the negative 3 raised to the negative 4 power. Power to a power, doesn't matter if they're positive and negative, you're going to multiply them. So this is b to the negative 3 times negative 4. Check this out. Negative by a negative becomes a positive. And this is just b to the 12th. Okay. Let's expand on this now. All right, when a product is raised to a power, okay, you're going to raise each factor to that power. Okay, so if you have in parentheses a times b to the nth power, you can think of it as distributing the exponent. And this only works if they're products, right? Like if there was a plus sign in there, if it was a plus b to the nth power, this doesn't work. Okay, it's just a times b to the nth power. Okay, so then you can think of it as distributing the n to the a, and then the n to the b. So it becomes a to the n times b to the n. Let me show you. So here's the first one. Suppose you have negative 4 times x, all right, to the 3rd power. So basically what you're going to do is you're going to distribute this. It's going to become negative 4 to the 3rd power times x to the 3rd power. Well, when there's no exponent here, remember there's like an invisible 1. All right, so negative 4 cubed, negative 4 times negative 4 times negative 4. So negative times negative is a positive, but then times a negative is a negative. So this becomes negative 64, and then 1 times 3, x cubed. If you have this one, 5x cubed squared, so you're going to distribute. You're going to get 5 squared times x cubed squared. Well, what's 5 squared, right? So 5 squared is 25. And then look, power to a power, you multiply. 3 times 2, you get x to the 6th. You can even expand this out. Instead of just 2 terms, if you have 3 terms. So let's look at 5 x squared y to the minus 3 to the minus 2. All right, so there's a lot going on here. So as long as it's a product, you're going to distribute to every factor here. So 5 to the negative 2, x squared to the negative 2, y to the negative 3 to the negative 2. All right, we'll now distribute. So this becomes 5 to the negative 2 power. 2 times negative 2, this is x to the negative 4. And then negative 3 times negative 2, negative times negative is a positive. This becomes y to the 6th. But look, now you have some negative exponents. How do you make them positive? You bring them down. So this is y to the 6th over 5 squared, x to the 4th. And then what is 5 squared? Again, that's just 25. Just like that. All right, this is quotient to a power rule now. So when a quotient is raised to a power, so if you have a divided by b raised to the nth power, okay, you're going to raise the numerator to that power and divide by the denominator raised to that power. Okay, so as long as b is a non-zero real number, again, just think about it as distributing, right? So you're going to go n to the a, and then n down to the b, and it's just going to be a to the n divided by b to the n. All right, let's try these. So let's look at this. Negative 2 over y to the 3rd power. So you're going to distribute the 2. So this negative in front, I'm going to attach to the numerator. So this becomes negative 2 to the 3rd power. And then also I'm going to distribute this 3 down to the y. Well, negative 2 times negative 2 is 4. 4 times negative 2 gets me negative 8. And this just is y cubed. All right, let's try this one. Let's look at x to the 5th over 3 cubed. All right, so again, distribute this exponent here to the numerator. So this is x to the 5th cubed, and distribute it to the denominator over 3 cubed. Power to a power, you multiply, so 5 times 3, you get x to the 15. 3 cubed, well, 3 times 3 is 9, times 3 gets you 27. All right, now let's begin by working some harder problems. And what we want to do is we want to simplify exponential expressions fully. So an exponential expression is fully simplified. Okay, so fully simplified when no parentheses. So if the problem starts with parentheses, you have to figure out a way to get rid of them. There are no powers raised to powers. So you have no powers to powers, like x squared to the 5th power. You have each base only occurs once, and there's no negative or zero exponents at all. All right, so we're going to work some. I got 3 problems that are a little bit harder here for these. Okay, so let's simplify the following. Okay, so remember, we have to have no parentheses, no power to power, each base only once, no negative or zero exponents. So here's the first problem. Let's simplify 2x cubed, or 2x squared, excuse me, y cubed. All right, that raised to the 3rd power times 3x y to the 4th power squared. All right, so there's a lot going on here. Okay, so the first thing you're going to have to do to simplify this, all right, you're going to have to get rid of these powers outside the parentheses. So you're going to have to distribute those in. Okay, so this becomes 2 cubed, and then look, 3 times 2, that becomes a power to a power. Okay, so 2 times 3 gets me x to the 6th, and then 3 times 3, okay, that gets me y to the 9th. Times, now distribute here. 3 times 3 squared, so 3 times 3, I'll write it as 3 squared though. X and then squared, you get x squared. And then y to the 4th squared, so 4 times 2 gets me y to the 8th. So then look, 2 cubed gets me 8, x to the 6th, y to the 7th, times, well, 3 squared gets me 9, x squared, y to the 8th. Now you're ready to simplify. Okay, 8 times 9, well, that's just 72. X to the 6th times x squared, well, 6 plus 2 gets me x to the 8th. And y to the 7th times y to the 8th, 7 plus 8, that gets me y to the 15th. All right, let's try this one. Let's look at 5x over y to the 4th, all raised to the negative 2. All right, so really what's hard here is this negative exponent. But look, let's just follow our rules. All right, let's distribute this. This becomes 5 to the negative 2, x raised to the negative 2 power. And then, remember, power raised here. So 4 times negative 2 gets me y to the negative 8. All right, so negative exponents in the numerator, whoop, you bring them down to the denominator. Negative exponents in the denominator, you bring them up to the numerator. Okay? So this y to the negative 8th just becomes y to the 8th up here. 5 to the negative 2 becomes 5 squared down here. And x to the negative 2 just becomes x squared down here. Well, 5 squared is 25. So this is y to the 8 over 25 x squared. All right, let's do one last one here, okay? And we'll have a lot going on. So let's simplify this problem. Okay, in parentheses, I have 27x to the 10th power, y to the 12th, divided by 3x to the 5th, y to the 6th, all squared. All right, so, I mean, there's a bunch of ways you could do this, right? You could distribute the 2 to everything first, but like what I think is easiest here, what I really think is easiest here is to clean up what's inside the parentheses. Okay, so before you distribute this squared outside. So start here, right? What's 27 divided by 3? That's 9. This becomes x to the 10 minus 5, and this becomes y to the 12 minus 6. Right, just following our rules, all squared. So this just becomes 9. X, 10 minus 5 gets me 5. 12 minus 6 gets me 6 squared. Now distribute. This becomes 9 squared times x to the 5th squared times y to the 6th squared. Well, what's 9 squared, right? 9 times 9 is 81. 5 times 2, this gets me x to the 10th. And y 6 times 2 gets me y to the 12th. All right, I know with all of these problems, with all of this stuff, it's going to be practice makes perfect. So what you're going to want to do is you're going to want to practice these problems as much as you can each week, and the more you do, the easier and easier this stuff will get.